Alright, in this next example again, I do not have the standard form of a quadratic. I need to have a 0 on one side, so I'm going to move everything around so that I have a 0. I'm going to get rid of the stuff on the right side. Okay? It doesn't really matter which side I put it on, but I like to have a positive x squared. It's just kind of my personal preference. So I'm going to move everything to the left. So I'm going to subtract the 8x from both sides of this equation. I'm also going to add a 7 to both sides. And so the left side will become 3x squared minus 8x plus 7. The right side, everything zeroes out. Okay. Now my formula, I have it in the right format. I need the a, b, and c. So the a here is 3, the b is negative 8, and the c is 7. Those are the three numbers we'll plug in. And again, I'm going to write out the full quadratic formula, every one of these, just to help to memorize it. So x is negative b plus minus the square root b squared minus 4ac all over 2a. Again, you've got to get that memorized. Okay, then I'm going to replace all the variables with empty sets of parentheses. So the b, and under the root we have the b, and then the a here and the c, and then I'm going to have the 2 and the a on the bottom. Okay, and again, all these parentheses get filled in. So the b's become negative 8. The a's, that's these two spots, become the 3. And then the c becomes the 7. And so then we simplify, right? So x is double negative on the 8, so that's 8. Again, here a negative squared is positive. 8 squared is 64, so it's positive 64. Here I have a single negative, so I get a minus. 12 times 7 should be 84, so it's 64 minus 84. And then all of that over 6. Now when I simplify under this root, I'm going to get, what's that, a negative 20? And now I have a square root of a negative number, which in the past we said we couldn't really do that. It's not a real number, but last week sometime we looked at complex numbers. And now we can go through, because this ends up being a complex number, I can go through and continue to simplify this. Notice that the negative under the root is what gives us the complex number. So if I continue to simplify, remember the square root of negative 20, I'll take this to the side, is the same as the square root of negative 1 times 4 times 5. And so there's a couple numbers under here that will simplify. So the square root negative 1, the square root of 4, the square root of 5, that's an I, that's a 2, and that's root 5. So those combine to be 2i root 5. That's the simplified form. So that's what's going to go in place of that root. It's 2i root 5. Still have the 6 on the bottom. Remember, the 6 will distribute to both terms on top. So I'm going to go ahead and do that. Call that 8 over 6 plus minus 2i root 5 all over 6. And I'm going to cancel the fractions down. So 8 over 6 becomes 4 over 3. And 2 over 6 becomes 1 over 3 if I divide those each by 2. And so my final answer, as I simplify this, is 4/3 plus or minus. Now this final fraction here is going to have a root 5 and a 3 and then the I. Now I'm going to move the I to the outside just so it's in a nice a plus bi format for our complex number. So it's going to become root 5 over 6 times I. All right, so my final solution set will be 4/3 plus or minus root 5 over 6 times I. Okay? So 2 complex numbers as a solution here. Now notice, if you're going to get a complex solution, it comes from having the negative under the root. Okay? Keep that in mind. All of the other examples I've done so far had positive numbers under the root, and we ended up with real number solutions. Okay? So just keep that in mind as we go through the next example.